My name is Jim Atkinson. I'm the president of the Granite Island Group. Thank you for having me come and speak today. We're going to be talking about telephonic defenses against the dark arts. This is primarily going to be talking about phones, how phones are bugged, where phones are bugged, how to stop phones from being bugged, how to audit voice over IP systems, historical, what some of the penetration points are, how to protect those penetration points, and all kinds of good stuff along those same lines.
Is there a way to go back into monitors and change the refresh rate? It's the videos going like this. Does anyone know how to do that?
Yeah, he just did it.
It's up at 75 hertz.
Change the shutter speed on the camera to compensate. What happens is you turn the overhead lights off, which, if you turn the overhead lights back on, it should clear up your flicker problem.
Yeah, well, actually, I closed the door over there. I closed the blind, but that's okay. I'll try to adjust it from here and see. But yeah, okay. Just keep
Okay. You have 6 primary weak points in the telephone communication systems that you need to be concerned with. We have the instrument itself, which is the proper name for the device you put your ear and your mouth to and that you speak into. Technically it's not a phone, it's an instrument. Then we have the local distribution or the in-house wiring. That's the wire that includes the jack, the wire that goes between the jack and the instrument, the wire that goes from the jack up into the walls and the ceilings and down to cross-connect locations. We have the local switch or PBX system, which most of your corporate entities and government entities will have. This can be as small as a bread box. It can be as large as a semi-truck. The local switch is something on your premises, not the phone company's premises. And at each of these, there's a different penetration point that somebody can hit. Then we have the demarcation or the network interface. That's where we go from your property to the phone company's property. We have the transmission system, which is almost exclusively owned by one of the phone companies. This includes your telephone poles, the fiber on the line, the copper on the line. This is stuff the phone company installed for their own use, not yours. And then we have the switching systems, also referred to as a central office. Now, from switching systems to switching systems, we have transmission systems between those. We can actually penetrate any of these 6. We can penetrate the 7th, which was the trunks between switching systems or central offices, fiber optic communications, and the list can actually go down another 10 things, but these are our basic 6 items. Everybody has one of these or a variation of these. These are 2 of the most exploitable phones made on Earth. This is an Avaya system. Anybody in the U.S. government probably has one of those. This is one of the old Merlin systems. These were great. They gave you 4 pair of wires. You only used 3, had high current, all kinds of mischief afoot with this. The Avaya system, well, let's just say the Avaya systems are notoriously insecure. And you can just have some horrific pawnage of an Avaya phone system. These are our wall jacks. Years ago, we only had to worry about 4 wires, 2 pair. This is the old prong jacks. Nowadays, we're looking at 3, 4, 5, and 6 connectors. Each of these connectors have 8 wires plus ground. So you can easily have 40, 50 wires in a single jack now, plus ground. And you only need 1 wire to make an incoming connection and 1 wire going out to make an outgoing connection, which is why we have to consider ground, because you may be doing a project and you're not getting audio on any cable pairs, but you are getting audio on the brown-white pair to building ground. We used to have 4 conductors. 32 is pretty much standard now. You could have 3, you could have 4. It could be ISDN services that have been retrofitted. The case in the middle is a situation where somebody had 2 voice telephone lines in their office and they changed to VoIP, which we're going to talk about. As you can see, the data network, this is their VoIP telephone. Very bad news. This is what is in the back of most of your phone boxes, or your phone PBX, your phone rooms, your cross-connect panels. A lot of people have never seen what the back end of one of these looked like. This particular one has actually been wiretapped. This was a brand new installation, and before the government agency that was going to be moving in here moved in here. Somebody actually disconnected the wires, put in a wiretap, and they got caught. But this is what a wiretap looks like. As you can see, there's nothing really visible. There's no magic black box hanging off of that. That is a wiretap. This is typically what we find up inside ceilings. This was taken at a defense contractor's facility. If you've been up inside a drop ceiling, these are your ceiling tiles. This is the back wall. This is a 15-foot high gap between here to here. It's a mad jumble. There's typical no documentation. It's rare to have documentation as to what kind of wire we have up in there. This is a very common problem. If you look very carefully, you'll see an audio recorder in there. If you look very carefully, I'll let you look at that for just a moment. This particular problem, it required us on site. This one mast took 4 days of digging through, identifying, auditing, tracing out all of the wires. We found the tape recorder right away. It was actually that very large black box down in the bottom. We found that right away, but then we had to go through and make sure that none of these other wires had anything else on them, because we always have to assume that there's 3 bugs. There's the bug you're designed to find. There's the bug you're going to find if you look really, really hard and spend tremendous amounts of time exhaustively searching. And then there's what we call the SPIES bug, which is a bug you're never going to find unless you perform every test known on Earth. Yes? I was wondering what was causing the noise. This is a typical hatchet job done by an amateur spy. What was interesting in this case, this wire did not initially exist. What happened in this case is the spy was not very skillful, so he went to Radio Shack, bought wire, literally wired this through conduit to another house, to underground conduit, went in, trenched in the cable, ran this cable from Radio Shack through the conduit. So when we followed this back down with tracing equipment, we traced it right to his house. The blue-white wire is the regular talk. You'll notice here we have orange going to the terminal block, but we also have another orange cable that comes out here. This actually went to a PBX phone. So what he had done is he had given his next-door neighbor a telephone where they had taken the orange pair. He had bought it from a spy shop. He had taken the orange pair and connected it directly to the microphone in the phone. So he had exploited the phone by modifying the inside of the phone so that you always had room audio on this pair, and then this was a regular telephone line. We go into the phone area, start looking at things, and we're going, wait a minute here, some amateur twisted these together. This is very amateur. Everything that he used was he bought from Radio Shack. It went to a tape recorder. The law enforcement authorities were highly amused when they came out and saw the hatchet job he had done. Basically all he did is he added a patch cable and did what we call a second pair exploit or a spare pair exploit. This is another typical defense contractor's facility. This one is bugged. Big questions: do we have extra wires? Do we have transmitters? Do we have recorders, bridges, taps, slaves? The slave is a type of eavesdropping device. In this particular case, we have the sack that comes up from the cable company over here. We have you'll tell the yellow are your digital lines coming in. This is the breakout panel for the central office. And within this board, we actually have a wiretap and a slave. On the next slide, you can see it better. I'll give you a little hint as to where it's at. It's a left. This is the 110 block. If you look on the left side and you count 9 rows down from the top, you see a little silver reflection. The spy, when he installed this particular slave, did not opt for a low visibility one. It was a nice stainless steel kind of difficult not to see if you had a strong light. It's actually behind, you'll notice it right here. And this cable was the actual cable that went back to the listening post. And this was at a defense facility, a defense contractor's facility. The only way you're going to find that, you can get lucky with a flashlight, which more bugs are found with flashlights than any other creature on Earth. Low tech, you get a dental mirror and a flashlight, you can find all kinds of stuff if you have enough time. An extensive physical audit and electrical audit will find this very reliably. The electronic test equipment can see things your eyes can't. So if you just use your naked eyes to try to find something like this, or a dental mirror, or very basic test equipment, you're going to miss this. This particular place had been through a number of sweeps before, not by us, but government sweep teams had come through and they had missed this. They estimate this was in place a year and a half and had been missed on 6 inspections because people just weren't paying attention.
Whose pair did it go to?
What's that?
Whose pair did it go to?
I'm not saying. But it became a federal case very quickly. This is what should be locked. There should be a lock on here. As you can see, there is chafing and abrasion to where a lock used to be. You can also tell by the scuffing and chafing on the paint that this container is gotten into on a very regular basis. Some of you know what this latch is to, some of you don't. That's what it's to. This is your typical cross-connection box. As a rule of thumb, they are not secure. Anybody who has the wherewithal can walk up to it, usually with no tools, just lift that handle up, swing that door open, and welcome to the gates of heaven. If they are latched, it'll be nothing more than a 5/16 or a 3/8 socket. You just put the socket on it, unscrew it, opens right up. If it is locked, usually all the padlocks within a 30-mile radius, it's all the same key. So if somebody has the key, and usually all you really need is a bobby pin to open these. They're nothing special, which is unfortunate from a security perspective. If you have one of these outside your home or your office, you need to go buy your own padlock and slap your own padlock on it and wait to see when that padlock gets cut off, and then play a game with the phone company called "They keep cutting my padlock off and I keep putting another padlock on it." As we actually recommend our clients play that game and just buy about 50 padlocks, and once a week security goes over, makes sure that their phone box nearest to their office is padlocked, and it'll drive the phone company nuts. But that's why they have bolt cutters on board all the phone trucks. And if you really want to be cute, eventually they'll put a padlock on it, and nothing will prevent you from putting your own padlock on it after that. There's lots of extra space. The pairs are often labeled. For example, I wouldn't recommend doing this, but God forbid somebody go up to the presidential estate in Kennebunkport, Maine. The president has one of these across the street from his house. It's unlocked. If you open it, his phone line is tagged. The Secret Service's phone line is tagged. When I say, I don't mean bugged, I mean it says Secret Service hotline. So these are usually remote from the target, and what I mean by remote, they're not under the immediate control of the target. So if there's one of these for the hotel, it generally won't be on the hotel property. It'll be down the street somewhat. These are very easy to access, and professional eavesdroppers absolutely love them. There is so much mischief they get into with these boxes. This is what the inside of one looks like for those of you who've never gained access to one legally or otherwise. You typically see these by the side of the road. They're generally not labeled. If they are labeled, there'll be a code, which will be like box 57, which indicates it's the 57th. Or if they're really fancy, if it's a fiber optic unit, they'll actually have the CLLI code, which is the network address code for that particular box. So the phone company can find it real easy. This particular one, for those of interest, this one was legally accessed. So if you look on the far left-hand or far right-hand side, these are codes written inside the door to include the password for the local maintenance system, so you can actually plug in, tie your computer into the local switch, and gain full access, perform all kinds of naughty mischief and so forth like that. Not that anybody in the room would do that. It also contains the 800 numbers to call customer service, the wire room, as well as a note down here as to which pair in the phone closet has the most salacious commentary, and the escort agencies and stuff like that. They're actually noted on so that the phone guys, when they're there working, if they're bored, they can plug in and listen to entertainment. Pair number 557 in this box was in fact tapped. This was what we were called in to find. If you look very carefully, you can see that the craftsmanship on this particular set of wires, the wire is the same because it came off this spool, but the craftsmanship and the installation technique is an amateur. A professional is not going to make this mistake. It's all going to be neat as a pin. That's one of the key things that you look for when you look in these boxes, is to see who's been working in it or on the junction panels or the terminal blocks that's not neat as a pin like it's supposed to be. If it's not neat as a pin, somebody's been fooling around there. It may have just been a drunk phone guy, or it may be an amateur wire guy. It may be a private investigator who does 3 or 4 installations per year. They tend not to be very good. They tend not to be very clean in their installations. This is one of my favorites. You open the phone box up and you're doing a sweep, and lo and behold, we come up with, it's a 56 kilobit line to a German company with the account code on it, the address, everything that a spy needs to exploit. This was not our client, this is somebody else. We're doing a project for a client, pop the box open legally, and everything in there is labeled. All the T1 lines perfectly labeled. This particular box, there was also a box in here that said Federal Bureau of Investigation and gave the address to their safe house where they had their listening post set up. Not exactly very smart move on the part of the phone company. Yes?
Sometimes those heads are vigorously defended by hornet nests.
Yes, they are. And hornet spray is carried on all the trucks, as are EpiPens. Fiber. Contrary to popular belief, fiber is easy to tap. Anybody who tells you otherwise know not of what they speak. Fiber is higher bandwidth than copper, which makes it very attractive to a spy because there's more intelligence on it. It's harder to detect because you don't have the major dropouts, and with a fusion splice onto fiber, which is the preferred way to splice into fiber, where you actually melt glass to glass, it's going to be very difficult to detect, and unfortunately, there's a huge illusion of security about fiber. You can have fiber that's just been pawned all over the place, and you're not going to detect it very easily. Do not ever think that a fiber optic network can't be wiretapped. It can be easily wiretapped, and you don't have to use anything more than a small handheld fusion system. And you can actually have 8 cables running in here. You're using 6 to set your rings up. You've got 6 fibers you're not using. You can actually bridge all of those fibers back to an off-site location. Did I see a hand? Oh. This is our typical fiber optic multiplexer outside. There are versions of this that are inside a lot of office buildings, even small suburban office buildings. Your local Walmart typically will have these. In the wild, you're typically going to see behind it is a copper back here. This is the copper sack. This is fiber optic. The code up here tells us what it is. Also the power. You don't need power for a copper system. You do need power, and lots of it, for a fiber system. If we go around back, we'll actually see a plug where we can plug in a generator in case we have an extended power outage. This is like a holy grail for an eavesdropper. 3,500 services in here, T1s, T3s, ISDN lines, DSL lines galore, 3,500 voice lines. When it leaves here, it leaves on this particular system, it leaves with this one had 2 fiber rings in it. There were 4 active single mode fibers, 2 inactive backup fibers, and there were 6 dark fibers. It was 3,500 active phone lines, a variety of DSL lines, T1s and T3s. If this was near a defense contractor and somebody hit this box, they would own that defense contractor. This is a terminal. This is not a network interface device. There are 2 terminologies that we have to be careful of. A NID, or demarcation point, is a physical location on a premises where you stop owning the wire and the phone company starts owning the wire. It is mandated by federal law. This is not a NID. This is a terminal. So we've gone from the client's home to the NID on the side of the client's house. We've gone underground out to the telephone pole. That cable between the house and the telephone pole the phone company owns. This box the phone company owns. This telephone pole the company owns. On the left, on your left, is what it looks like closed. As you can see, there's no padlock on it. This is at eye level. When it's opened, you have access to 2 phone lines, and technically you have access to 6 cable paths because you have ground here, and you can set up on any combination of these 4 wires to each other or in reference to ground. Plenty of space in there to put a tape recorder, plenty of space to put in transmitters, recording devices. I've seen these with video cameras hidden inside of them. This is a terminal block. Phone company owns it, phone company controls it, phone company doesn't care about it. Unless it falls off, they don't really care. This is a pedestal. Many of you have seen these outside your homes. In New England, we don't see them as much unless it's new installations. This is typical of what we see down south. The numbers that you see on the bottom are very critical. If you see one of these open, which as we see on the side is opened, when you call the phone company, you want to give them the 30601 number because that tells them the exact location. They can come out, they can close it up. This particular case, an amateur had opened the box. He knew how to open the box and alligator clip his tape recorder onto it, but he didn't have enough sense to close it back up when he was done, and he got caught, and there were his fingerprints all over everything. This is, we call this the boot, also called the easy access point for those of us in the industry who have things like bucket trucks and very tall ladders. We can get up there, and if we have the legal authority to do so, we can open these boots and inspect them for all kinds of mischief. Usually the cable goes from your NID, or your demarcation point, through the air to the telephone line, to the telephone pole, or the cable where it's anchored, and then it goes into this easy access facility. It loops around. It's referred to as a drip loop, so when water hits it, it drips off the bottom of the drip loop, and then we go up into a splice case that runs along the main distribution cable. So this main distribution cable may have 900 cable pairs in it, but we only need 6 here, and since we only need 6 or 8 here, and when we overgrew that, we just slice in, clamp this over where we splice in, and splice in our extra wire. Very commonplace to find professionally installed devices. This is typically not where you're going to find a device that's been installed by an amateur. You're not going to have a husband bugging his wife from this unless he works for the DEA or something. This law enforcement likes to hit these locations because most people don't have 15-foot high ladders, and if they do, they get vertigo when they clamp it on the cable strand. And when you hit these, you either hit it with a bucket truck or you literally clamp your ladder over the top of the cable, climb up the ladder, and it's not that difficult to do. And if you're prone to vertigo, you don't want to do this. It's very straightforward. Within the local transmission network, we have poles. This is actually a bit of an art form. You have to understand what pole codes are. When you call something into the phone company, you have to have those pole codes. So, for example, if somebody ran their telephone or their car, sports car, into this telephone pole in the center, we would want to call the phone company or the electric company, whoever owned the pole, and there actually is a marker, which you can see here, which has the name of who owns that pole. You would call in that there's a black Porsche 911 wrapped around
Well, there's a
line.
Dodge Charger, and those poles are expensive when they make you pay for it.
Yes, they certainly are. This is line number 754, pole number 8. This is similar regional area, but this is line number 100, pole number 137. Now, there will be a database that the phone company and the power and the cable TV company has of every single telephone pole that they string wire on, because if this is an electric company telephone pole or an electric company pole, the phone company has to pay rent to the electric company. If you're a major corporation and you've got a facility at MIT and a facility at Harvard and you don't want to dig a trench, you're going to rent pole space from whoever owns poles, and you pay X number of dollars per pole per month to go from point A to point B. Within the counter-surveillance industry, we have to create that database for our client. So we actually have to go out, we go, here's the central office, here's our client's location, here's a mile and a half from point A to point B, but we have a problem because that cable is 5 miles long. So we have to chart out every single telephone pole within that 5-mile cable segment, not from the central office to the client, but from the central office to the end of the cable. So if our client is 30,000 feet away and it's 15,000 feet away and it's a 30,000-foot cable, we're going to take 3 days just to count the telephone poles, and we have to have an exact to-the-inch measurement of the distance from pole to pole. Because when you start doing a bug sweep, we shoot signals into the power lines, believe it or not, the power lines, the phone lines, and the cable TV lines, and we have to know where everything is, where everything's bridged in. We have to know where the boots are. We have to know where the terminals are. It has to be meticulously mapped out, and you can easily burn 1,000 pages up in 3 days auditing 200 poles. All of the phone wires, all of the phone cables, all of the fiber ends up somewhere. In this particular case, everything in the city ends up on this one telephone pole. If somebody runs a truck into this, the whole city goes dead. We have a little bit of fiber. You can actually see it coming in here. Since this is a rural community, they have one fiber cable for the entire city. All of the copper comes in here, and the rest of the copper comes in here. So this is approach from the north, approach from the south, and then this is the fiber connection that goes out. The small building you see behind it is the spinal tap where everything comes together. This is the central office for this city. This gives them DSL service, cable TV, everything is in this one building. Small generator behind it. Since 9/11, most of the phone companies have peeled off most of their external markings because they don't want to advertise with the big AT&T Death Star logo that, you know, if you blow this building up, you're going to cripple the city. They haven't peeled it off all of the buildings. They've peeled it off most of them, but this Christmas tree, or what we call the spine, is a dead giveaway. There's a major telephone facility there. Usually the smartphone companies and the smart corporations, they put their spine half a mile away from a sensitive facility. In this case, I think it was 25 feet from the building. This is the demarcation, or the NID, network interface box, that I spoke of earlier. It looks harmless. Pretty much everybody in this room has one of them hanging off their office, off the side of their house. Some people may have 2 or 3. From the outside, it looks like nothing. Everybody ignores it. Spies love it. This is what the inside of one of them looks like for those of you who haven't seen them. Inside of this box, we have cable that comes in from the street, splits off to the first pair, second pair. These blocks are lightning arresters, so if lightning strikes your telephone pole, your house doesn't catch fire. It actually was a problem when they first started installing telephones. People would get a lightning strike 4 miles down the road, and then their barn would burst into flames. And it was traced to the phone lines. This is actually bugged with one wire. If you look very carefully, you'll see that there's an extra wire that's tucked in behind this. It's a black wire. And so the spy went from ground across like this. So we have 4 conductors for the telephone, and we have ground, and ground can always be used as a return path. So you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could actually have 10 bugs hooked up, all with their own independent paths, and it would work quite well. Now inside this box, this whole area up here, this whole area down here, you can easily put 9 illicit transmitters in this one box. You could put one very large tape recorder to catch both lines. It would be very easy to do. Merely put it up here or down here, and it would record for 3 or 4 weeks before somebody had to come back and get it, or drive by and Bluetooth to it. There is enough power on these cable pairs to run a device until the end of time. Yes?
So I used to have one of those, but now fiber optics.
Fiber optic internet service.
You get the box.
Yep.
Just the screw, just the modules coming off.
Yes?
Are you covering that in your presentation?
Yes.
Okay, I won't get it.
That's okay. If you haven't had the opportunity to do so, I recommend you explore this. There's 2 ways to get into it. One is a screwdriver. You use a screwdriver that lets you in the civilian side. Then you use a special tool called a CAN tool, which is what we have here, lets you in the secure side. Okay, which is, you know, we refer to this as the Windows approach of security. You know, anything will get you into it. Now, once somebody is inside this, they can put stuff in. We actually have clients that will go out, we'll do a sweep, and we'll epoxy the box shut. Or we'll have their alarm company install a switch on this box so that if anybody jiggles the box, or if they open the box, it trips their alarm system. Now, on the instrument itself, we'll go back to the phone system, the actual phone. The most common exploits that we see, vulnerabilities that are exploited, is a speaker or microphone exploit. That's where we take a spare set of wires, we run it into the phone that's usually there already. We tie a set of wires to the speaker or to the microphone or to the ringer, because most of the ringers, the piezoelectric ringers that make your phone ring, you can use as a microphone quite clearly. Typical office telephone, you've got 3 or 4 transducers that you can exploit to collect room audio and channel it out of the room and never interfere with the operation of the phone itself. A spy can install a foreign device. We refer to a foreign device as a bug. It can be a slave device, a recording device, a transmitter device. The problem is it's very easy to catch those. People in our business actually have been known to blow a window place and within 15 minutes found the device, and then the client's upset that he's paying us for 3 days' work. A hook switch manipulation. A spy is not going to install something in the phone. A spy is going to manipulate what's there already. And we're going to cover this in a few minutes. He will manipulate the hook switch, which is an integral part of the telephone, and he can do some fun stuff with that. What the hook switch is doing is it's providing a mechanical and electrical disconnect from the speaker and microphone so that the speaker and microphone do not work when the phone is hung up. And that's what the hook switch does. There's firmware software exploits, for example, with the Avaya systems. You can absolutely raise havoc by doing slight modifications to the phone itself or to the switch itself, or in the case of Northern Telecoms, you don't have to do anything to the telephones. You do it to the switch because the phones pass room audio all the time. Not a good thing.
Siemens too.
What's that?
Siemens too.
Oh yes. Toshiba's do it, the Mitels all do it. And it's unfortunate because a spy has to really do nothing. He doesn't even have to come into your house. He doesn't have to come into your office. You'll never catch him in your office because that's not what he's doing. He's going to the phone room. And the phone room is behind the electrical closet, outside, behind the smoke place, behind the kitchen. A good spy can actually hit your phone room, be in it and out. Yes?
Just a comment on that. I used to work in the World Financial Center.
Yep.
The phone closet was in the ladies' restroom.
Yeah. Yeah. I was just at Rockefeller Plaza, Rockefeller Center on Sunday. I went from the secure area, they called secure area, through a locked door legally, put in 8 simulated devices, dummy devices, and was back out in less than 30 seconds. They were very upset. They were very upset because there was duct tape on the door. So, now, the problem with the instrument, moderately protected, but it's very easy to subvert. Everybody has seen these. These are the bane of my existence. 3/4 of the clients, we go out to their homes, including people who work for the legislative branch, the executive branch, and the judicial branch. 90% of the time we'll find these in their homes. This is a $20 cordless telephone. There's 0 security. There's 4 primary bands. Every 12th grade script kiddie knows what those frequencies are. You can go to Radio Shack. You can buy a scanner. Radio Shack will put those frequencies into the scanner for you at no charge, or they used to. They're really bad news. When you use this, you've bugged yourself and you're a clueless user. Very straightforward. This is a 900 megahertz. Somebody gets a scanner. They just set it to tune from 902 to 928 megahertz, and they listen in for all they're worth. There have actually been cases that I've been involved in where somebody wanted to buy their neighbor's property, or they had a dispute with their neighbor. So they bought all of their neighbors these phones, sent them to their neighbors as Christmas presents. And they actually had scanners that were scanning and recording all of their neighbors' phone calls. Now, it cost them 20 bucks a neighbor. Then the fools took the tapes, sent them to the neighbors to try to intimidate the neighbors into leaving the area. They got caught. It's actually fairly easy to catch somebody eavesdropping on these cell phones. We look for local oscillator radiation from the receiver. So what we'll do is we'll throw a signal on the airwaves, wait for a few seconds, let the scanner, the person scanning it, wait for their scanner to lock onto that frequency, and then we just take the IF, subtract it, or add it to the 915 megahertz, and we now own the spy. And you can usually catch the spy out to about 300 feet like that. So if the spy's within 300 feet, which they usually are, we can catch them, no problem. This is at a defense contractor. I'm not kidding. This is an off-the-shelf 900 megahertz old cordless telephone. They had a problem. Their boardroom secrets were leaving the boardroom. They weren't doing classified things in the boardroom, but they were discussing how much they should rape the government for, who they should fire, how they should negotiate with the welders, and so forth. They were baffled. They had bug sweeps done. Bug sweeps didn't turn up anything. They brought us in, walked in, said, pay us. We've just found the problem. And then it was just going through the formalities after that to make sure there was nothing else there. Once this phone was removed, all their problems went away. The problem with this phone is it was transmitting room audio all the time. We actually caught this in the parking lot before we even walked in the front door. So we hadn't even turned the truck off, and the truck's locking on. So we hit a few keys, brought a Spectrum Analyzer online, and actually went in and showed the client and says, do you recognize the room audio? Well, yes, I can hear my secretary in the background. Well, do you think this is maybe a bad problem? Where do you have a cordless phone? We don't have any cordless phones. Oh, beautiful. Go out, get the Yagi, set it at 900 megahertz, get the Spectrum Analyzer. Yeah, you do. It's right here in the boardroom. Oh, shit. This is a Mitel telephone that has been pawned. There was one modification that was done to this phone. One component that you can buy 100 of for a penny was added to this phone, which turned the phone into an eavesdropping device. And all it did is it connected, this is the speaker, it connected one line of the speaker to a spare pair on the jack, and it transmitted the audio from the microphone all the way back to the listening post through an unused pair. It's absolutely essential when you're checking your phone systems out, you do not have more wire than you need. If your phone system needs one pair to operate, by God, that's all you put in is one pair. If you put in 2 pair, you're tempting fate. If you have voice over IP, I'm not real fond of that, but if you have voice over IP, you want to have confidential discussions, you need 4 pair unless you have power over Ethernet, in which case you're going to have, well, you're going to have to 4 pair for power over Ethernet, but you're going to have 2 pair to get your basic connection. This phone, for a fraction of a penny, was compromised. The way you catch this is you go to the wiring blocks, you go across it with a voltmeter, or you go across it with a spectrum analyzer or with an audio amp, and you just basically you listen into all combinations of the wiring. It will give it up. When you do your physical inspection, which is done at the later point, you do your electrical inspections first so that you don't tip off the spies to what you're up to. And as you get towards the end of the project, you start taking things apart. You always take apart the phones because things can be done to the phone that will only throw off a signature for a couple of weeks, couple of months. The phone, if the customer hangs a phone up too hard at one point, he may knock something loose, and that something won't show up electronically. So you've got to open these phones up and check them out because you may find a bug that's been in place for 3 years, but it hasn't operated in the last 6 months. How are we doing on time? Yeah. This is an X-ray of a telephone. For those of you with very good vision, will notice alligator clips. And you'll notice wires that shouldn't be there that come down to a large transmitter that's taped to the back of the speaker. Now this is the handset here. This is the speaker that's in the telephone itself. It's transmitting room audio all the time. You will find that by an RF detection device. You'll find that with close field probes. You'll find that with a frequency counter, something very inexpensive you can find that with. The best way to find it is physical inspection. So all the electronics in the world can't, I mean, they can be beat with a flashlight and a small dental mirror. This is a Polycom speakerphone. I'm sure many of you have seen these in corporate boardrooms. This particular one had a bit of a problem. We opened it up, checked it out, found that a diode was missing from the surface, or from the surface mount diode was missing, and we found where the diode was missing, a capacitor had been installed. Well, the problem with that capacitor is it now allowed audio to be bridged out of the Polycom speakerphone. So the speakerphone was passing room audio all the time. Unless it was unplugged from power, room audio was always on the cable pair. It was hostilely induced. They did determine who did it. We determined how they did it. And if you looked at this very carefully and you didn't know what you were looking at, you would not notice something is amiss. But when you do your instrumented analysis, you hook up your amplifiers, your spectrum analyzers, your oscilloscopes, voltmeters, and you go, wait a minute, we have audio. We shouldn't have audio. Something isn't right. You have to trace down to see what happened. It took hours of checking this board out to figure out that somebody had pulled a diode and added a capacitor. Now, your local distribution, this is the cables that run in the walls and the ceilings, that run in your riser closets. This starts at the instrument and includes the wires that go from the instrument to the wall plates themselves, the raw wiring in the walls and ceilings, the wires in the riser closets, the phone closets, the cross-connect points, the IDFs are typically your risers or more regional wiring blocks, your MDF, which is your main distribution frame, that's in the phone closet. These locations typically are not protected or supervised. Somebody can get a ladder, pop a ceiling tile up, gain access to all kinds of wires, bug the wires. You're not going to see it in the phone room. They may or may not crash the phone. They may or may not throw an error code on the PBX system. The IDF and MDF closets, if the user is smart, they will put an alarm so that they know when those doors swing open, but you can't protect ceiling tiles. It's not practical to do that. If you have a wiring closet, be it an IDF or an MDF, you know, a riser closet, electrical closet, phone closet, network closet, put an alarm sensor on every door. If you have 2 doors that open, alarm both doors, put a latch plate over the latch so the latch can't be jimmied. And if you can pull it off, put 2 sensors on every door. A magnetic one up where the spy will be expecting it, and then down low underneath the lower hinge, put a switch that's not a magnet, but an actual switch, so that if they bypass the magnet at the top of the door, which is a popular target for bypassing, when they swing that door open, they're not generally going to recognize the switch on the hinge plate. My preferred place is to put a piezoelectric transducer on the back of the inside of the hinge. So what I'll do is I'll take the lower hinge, I'll take the hinge off, bore out a hole, put a transducer back there, epoxy it to the back of the hinge, and then screw the hinge back in place, and then call the alarm company to come hook it up. That way, if there's any vibration at all or mechanical movement of the hinge, it triggers the alarm. Strongly encourage you to do that. This is a typical IDF rat's nest. This is a riser at a local business. They gave me permission to use this because I helped them clean up a problem. These are the cables that go to the main phone closet. You can also see some fatter cables here that go to the main phone closet. These are the connections that go out to the individual telephones, and these are the cross connects for the 110 blocks. This is a rat's nest. If you're going to find a bug in that, you're going to have to go through every single wire to find it. It may take you a week to 10 days of working 12 hours a day to clear that. If you think software auditing is tricky, try hardware auditing. Now, the local switch, this is the PBX system in the basement, in the attic, in the riser closet. This is the PBX system in the building that you own, not the phone company owns. The primary 6 penetration points are the cross connections to the main distribution frame. These are the ports coming into the switch from the instruments. The switch input-output ports, so you may have a line card or a station card. The very common one to hit are the output ports to the voicemail server. So somebody will put a transmitter across the ports for the voicemail server, and every time somebody goes to voicemail to retrieve a message or type in a password, they're receiving that. It's actually a fairly popular hack. There's also what we call the PCM backplane, where somebody accesses the timing backplane on the switch, and they just capture everything that goes across the switch. And I mean everything. If you have a phone switch like your Siemens switches, they transmit room audio across that backplane all the time. So you can bug every single phone in the entire company by installing one transmitter in the phone room. We have what we call parallel channels. That's where channel A is bridged to channel B, or something is bridged and paralleled. So we have station A appears in multiple locations, not through software, but through hardware. Then we have switch software or firmware exploits, and there's hundreds of these. Every company seems to have 100 or 200 exploits for the phone and exploits for the PBX. Avaya's got their batches. There's things you can do to the phone. Cisco's been savaged several times through their voice over IP telephones because they just don't have decent security. They have security, but it's suitable for stopping a 16-year-old kid with too much time on his hands. It's not going to stop a 24-year-old college graduate. It's just going to slow him down and give him a source of amusement. And that's it. The local switch may or may not be protected. It usually is not protected. The doors usually are not alarmed. There's usually no video in these closets. There's usually no intrusion systems. There's usually no motion sensors. They're completely ignored. And I've seen cases where homeless people were living in the phone rooms, which is tragic. in Cambridge, too. Now, the demarcation and network interface, that's the gray box on the side of your house, is ripe for exploitation. We see a lot of domestic cases where a husband gets upset with a wife. That's where he's going to throw a bug down. Or the wife gets upset with the husband. That's where she's going to put the tape recorder. Sometimes they'll put it into an extension, but for deniability purposes, they'll put it outside the home so that way they can say, I don't know anything about it, some PI must have snuck up and done it. If he did it inside the home, you can only pin that on a couple of people. It's poorly protected. It's very, very rare to ever find them even cable tied shut. We have customers who will cable tie it shut. We'll come back a month later and somebody's cut the cable tie off. We'll epoxy it shut. We'll come back a month later and somebody's taken cable cutters and hacked a hole into it because they were trying to get in there to retrieve their bug. We've had cases where we've been involved in law enforcement cases where there's a bug and they have us epoxy the box shut and then pull one of the wires loose so that it intermittently makes a connection, or we'll give them a small switch so they can turn the bug on and off, and they epoxy the box shut so that the only way the spy can retrieve his bug is to come break the thing off the wall. They're very target specific. If this is on your house and I want to bug your house, I can come bug your house by visiting your house and never coming into your house. It's a significant choke point. In tactical school or SWAT school, there's this thing called fatal funnel. That's the part where the SWAT team lines up and everybody comes through one door, one person at a time. That's where a lot of SWAT team members get killed. This is a fatal funnel of communications, is that network interface box. You've got to protect it, lock it down, epoxy it shut, go out there, open it up periodically, check it, see what's in there. The local transmission system, this is between the NID and the central office. This is before the switch at the central office, but it allows us to very easily isolate a single subscriber. So, for example, I know that you're on cable 52, pair number 557. Phone company database says that. Or you can pull, not somebody's phone bill, but you can pull up their subscriber record and it will say they're on cable 52, pair 557. You don't even have to go to their house. You just go out to the local cable cross-connect box, you open a box up, you go down cable 557, you just plug on, you've just bugged the guy's phone. Their terminals are frequently open. Boots are usually, there's no lock on boots. Most terminals are unlocked. Most cross-connect boxes are unlocked, or if they are locked, it's just with the wrench. They're not protected for any practical purposes, and they're wide open for mischief. At the central office, they used to be huge buildings in the middle of a city. For example, in Cambridge, we've got one that used to, initially it was supposed to be the NASA control facility that they were going to build across the street or down the street here. They built a huge phone company facility. NASA decided to go to Houston for mission control instead of MIT due to politics. That's an example of a monolithic building. Across from the FBI building in Boston we have one, then down on Franklin Street we have one. Those are what we call a monolithic building, where they would have 8 buildings above ground and 8 stories above ground, 2 stories below ground, generators, turbines, batteries, operators, people sleeping there at night. This was back during the Cold War era. As we got into the 80s to the breakup of the Bell companies, to using less and less and less electronics to do the phone switching, they didn't need as much space. And now if you go into a lot of these buildings, you can go in there and play racquetball and not hit anything. You can put basketball courts in some of these buildings. They have these huge cavernous buildings, and to support a city like the size of Salem, Massachusetts, they used to have a building that was bigger than this hotel. Now they have a room that's the size of this room that supports the entire city. Post 9/11, they've removed most of the logos that indicate, not in all cases, but in the vast majority of cases, the phone company is very nervous about mischief. And in most cities, for example, in Boston, if somebody got a pair of bolt cutters and a shovel, one guy could take Boston off the grid in less than 45 minutes with nothing more than a pair of bolt cutters and a shovel, just by knowing where to dig and what to cut. It's a big problem. There's what we refer to as an overt choke point. People who do eavesdropping know where these facilities are. They know their choke points. They are generally highly protected and highly alarmed, but the cables just outside are not. Where the cables run, for example, if we go up to Waltham, Massachusetts, big network operations center up there. You go a mile away, you don't see any cables running in the network operations center within a mile. You get just outside a mile and you see these cables that have 3,600 pair in them, all shooting underground a mile away from the network operations center. Somebody goes out there with a chainsaw and they cut it, half of Boston falls off the face of the earth. And it'll take them 3 days to get it back up. The buildings are protected, the cables usually are not. They're usually very cleverly concealed, and usually not that cleverly. Now, the transmission networks, this is usually between central offices. These days, it's mostly single-mode fiber optics. Again, fiber optics are very easy to tap, very easy to exploit, more security-wise, they're very easy to sabotage. Somebody can very easily sabotage 2 or 3 fiber optic cable runs, not individual strands, but cable runs. So if somebody goes out to Route 128, cuts a cable there, then they come out here by MIT, they cut another cable, then they go over to Franklin Street and they cut another cable. One guy, a shovel, bolt cutters. He's digging a hole 2 or 3 feet down, except in the case of MIT, he's just taking a crowbar and moving a hatch cover over, sticks his cable cutters down in there, cuts one cable, Cambridge falls off the earth. He goes out to Waltham, cuts one cable, Waltham falls off the earth. Go to Boston, cut one cable, Boston falls off the earth. 3 days later, we finally come back up. The vaults sometimes are alarmed, but not the cables. The phone company knows when the cable gets cut and where it gets cut, but they don't have any way of preventing it. You can actually walk 300 feet out the back of the hotel to the train line and walk right on top of AT&T long line fiber. And if you were so inclined, I wouldn't recommend doing this, but if you were so inclined and you had mischief in mind, you could actually lift a hatch cover up with nothing more than a crowbar or a stick and lay your hands right on single mode fiber that connects everything together. It's not protected. The phone company building is protected. The cable vault where it all cross connects is protected. The manholes are not connected, and most of the switching systems may or may not be connected. So when you're looking at this from a security perspective, just because the building is protected doesn't mean that which interconnects the buildings is connected or is protected. I hope that made sense. Voice over IP. Couple of problems here. There's voice over IP is very commonly implemented over a cable modem. We refer to these as fool's phones, because if you take a DOCSIS modem, which is a cable modem, and you plug an IP phone into it, you now have cheap phone access, but everybody in your neighborhood can listen to all of your phone calls, because DOCSIS or your cable modems is a shared communications media of everybody in your neighborhood. It is called a bus topology, which means if this person over here is surfing a porn site at 3 o'clock in the morning, 3 doors down, his neighbor can be eavesdropping on him surfing the porn websites at 3 o'clock in the morning. Do not use voice over IP over a cable modem. You're compromising your security and your privacy if you do that. If you want to go VoIP, do it over a DSL connection. Don't do it over a cable connection. There are some vulnerabilities with DSL. Yes?
What's the percentage of the cable providers that are actually utilizing the privacy mode for DOCSIS specifications, where it's supposed to be encrypted between the front end?
70, 75%.
75%?
Yeah.
More?
Most of them are setting it up for DOCSIS 2, not DOCSIS 3.
Right. So with that in place, is it still that bad of a problem?
Yeah, it's a 56-bit key. 56-bit key, you're not talking minutes to break, you're talking milliseconds. And you're not talking about NSA supercomputers, you're talking about Best Buy on sale for $1,200 computers. Unfortunately, broadband services, VoIP over a broadband service is dangerous. If you're going to go VoIP, do it over DSL, but also it's no more secure than a regular telephone line. If you're in a hotel somewhere, don't use VoIP. Not a good thing. Be very cautious about broadband services. One of the more clever implementations I've seen are companies that offer EVDO access. So you can use like Skype on your cable, on your laptop when you're on the road. Then they go EVDO through it's encrypted software on the laptop. They go EVDO back, so you have a wireless connection. Then there's a gateway that decrypts and injects into the voice network. ISDN used to be very popular. It's now fading out over VoIP. Most companies who have VoIP, they're not using ISDN anymore. Fiber optic internet service is becoming very popular. I highly recommend it. However, it can be tapped. Don't ever think fiber optic cannot be tapped, because it can be done very easily. As a rule, a fiber optic connection can be tapped by inducing less than 0.5 dB of signal loss. You're not going to detect it unless you do a physical inspection. If you have to have what we call telephonic integration, go with VoIP, but do it over DSL lines. I would recommend not doing it at all. It's very dangerous. The realistic threat, we have various types. RF is the realistic threat, where somebody runs up to your phone, they install a transmitter, it transmits it. This is very beneficial for the spy because he can now air gap himself from the bug. So here's the bug, he is 500 feet away, he only has to hit your building once to install it, and he can be 500 feet away, and he doesn't have to come back on your property again. Now, if it's a hard exploit or modification that does not involve a transmitter, for example, like we saw with the orange-white pair, that cable, it was just a simple matter of throwing an ultrasonic tone on that orange pair and see where the underground cable went to. Spies, an illicit spy generally is going to turn to an RF device. A professional spy or law enforcement spy or intelligence type of project, they're going to go hardwired if they can. Unfortunately, there's a lot of cases where they can't do a hard exploit or hardwired recorder, and they have to have an RF link in there somewhere, which the RF link makes it very easy to pick up. There's wireless intercepting, where somebody has like a rural switching center. They may not have fiber out to that switching center. They may only have like 4.4 gig microwave link or an 8 gig microwave link from station to station. Back in the 60s and 70s and early 80s, this was a real issue because they didn't have high-speed connection, but over hard lines, but they did have it over the airwaves. So there was a tremendous amount of microwave activity going on. Nowadays, for example, with GSM phones, the GSM connection from the GSM handset to the GSM base may or may not be secure, but once it hits the base, the X-band or the 10 gig transmission from site to site is extraordinarily easy to intercept and extraordinarily easy not just to target one phone, but every phone in the network. And there will be some presentations later on in the conference that talks about that and how to deal with that, and I strongly recommend attending Frank's discussion on this matter because he's going to cover it in really good detail. There's also software manipulation of the phone switch, of the PBX, of the phone itself, the central office. The multiplexers can be exploited. There's also other methods that we don't need to get into. If you're available afterwards, I'd be happy to discuss some of the other methods. I'm not going to tell you how to do it. I'm going to tell you how to defend against it. The defensive tasks are fairly straightforward. Believe it or not, it's as simple as this. Inventory your conductors. How many wires do we have coming into this room? Map the pathways. You throw tone, or you get up on a ladder with a flashlight and you identify where every wire is. Then you take a set of electronic metrics. This is where you shoot a pulse into the phone line, power line, cable TV line, LAN line, and you identify how long is it and what has been installed along the way. So you may have, you're going along, you install or you insert a ping, and then you see how it comes back, and oh my God, we have a huge return pulse right here. Well, we have to go right here and see what's causing that. It could be a bend in the cable, it could be a bug on the line, it could be a microphone there, it could be a transmitter there. But we have to do a conductor inventory, determine what conductors are in this area, then map where they go to, perform a series of known electronic metrics, preferably when the system is first installed and commissioned, not 3, 4, 10 years after the fact, because that's a waste of everybody's time. You want to do retesting against the metric. If you don't have a metric, then you have to do what's called open testing, where you have to collect these metrics from scratch. You have to have physical inspections always, and you have to periodically repeat all of the above. Now, if you know that there's 25 wires in this room, and 6 months later you come back and there's now 30 wires in this room, you need to find out why there's more wires here now than there was before, and does the person in that room know why? Because he may not know that those wires were installed. He may have absolutely no idea why those wires are installed, and you start asking around, you start taking some measurements, and they lead to right here where there's a hole in the ceiling tile. And those wires exactly reach to where that hole in the ceiling tile is. So we follow the cables back this way, and there's a videotape recorder hooked in. Well, that's probably where a camera was. So those 5 cables may be there to support, and I've had cases where I've gone into a client's office, popped the ceiling tiles up, and there's coaxial cables sitting there. Next to the coaxial cable sitting there, there's a flashlight that's still turned on. And on the floor, there's footprints to where the ladder was just a few hours before, when the spy heard we were coming in, rushed in, popped the ceiling tile up, took his camera out, took the wire, balled it up, and threw it 12 feet this way. So we're like, oh, this is interesting. Traced the wire out, and he is 50 feet away unhooking his digital video recorders. He left his flashlight in the ceiling, and okay. You have to inventory every conductor up there. You've got to map out the pathways. You've got to repeat, rinse, repeat, rinse, repeat. When we're auditing the telephone instruments, by the way, we're in the home stretch here, so we're doing pretty good on the time. We have to know what kind of phones they are. We have to know what the phone's soft underbelly is. If it's a Siemens phone, we have to know the underbelly. If it's an AT&T Merlin phone, we have to know what the soft spots are on that phone system. If it's an Avaya or a VoIP, we have to know what the vulnerabilities are. Does the phone require 3-pair? Does it require 4-pair? Does it require 2-pair? If it requires 1 pair and there's 4 pair there, why do we have more wires than we need? This is not so much a problem in the corporate world, but in the government world. In a classified environment, you do not have any more wires in the room than you absolutely need to do your job. And ideally, if you don't need that wire, you cut it back 30 and you pull it 30 feet back out of the area, because you don't want anything in the area that you don't absolutely positively need. And I can always tell the feds in the classroom because their head's going like this when I say that. Now, we have to define with the instruments what should it normally be doing. If it normally passes room audio in an unmodified state and it has room audio on it, that doesn't mean anybody did anything to it. So you have to know what the phone can do, what it has done in the past, what the exploit points are, where the areas of concern are. If you find something, you have to make the determination, is it a threat? It may not have been hostilely induced, but it may be a threat. A good example is certain types of not intercom, speakerphones. When you use the speakerphone, it transmits a tremendous RF signal that you can pick up 1,000 feet away. It's not a hostilely induced device, it's a flaw in the design of the telephone. When Rockwell came out with the Rockwell data pump modems, one of the big problems with it is the FCC didn't like the modem because when people would go off hook, it would jam the local FM radio stations. And you could actually take an FM radio, tune it to a certain frequency in the FM dial, plug it into the audio jack of your computer, and listen to passwords being typed. Is it a design flaw or is it a hostile manipulation? And if it is a threat, what can we do to mitigate it? Is it a feature, a hazard, or a risk? These things are a key mantra in our business. Is it a feature, a hazard, or a risk? One of the most important things you can do to do a wire path audit is a flashlight, which you can see my flashlight here and my spot on the wall from the flashlight, and a ladder. The ladder has to be tall enough that you can get up in the ceiling. Safety tip, your belt never goes above this point. It never goes from side to side from this point. It never goes above this point. So you have to have a ladder or ladders tall enough to get you up into the ceiling. In some cases, your ladder may actually be touching the ceiling. In this particular case, I think this was a 12-foot ceiling and an 8-foot ladder. Yes?
You haven't worked in theater, have you?
Not yet. Give me time.
Top step it all the time.
No, I realize that. I've actually had a couple of acrobatic stunts, shall we say, where I was standing on the top step of a 12-foot ladder, and apparently the laws of physics decided it didn't like me that day, and ended up in the emergency room a short time thereafter trying to figure out what I was doing under the bright lights. So I preach, thou shalt not go above that. Now, to do a wire path audit, you don't need $1 million of equipment. You need a flashlight, a notebook, a tone generator that costs $200, and note paper. That's all you need.
And a lot of time.
And a hell of a lot of time. It's not something that you can come into like a room like this. You can't come in here with 2 guys and knock it out in a day. You can come in here with 2 guys and still be here a week later. Now your client is paying you too by the day, but you have to do a proper job. Like if this was like a conference room that classified information was being handled in, and you're just here to do the wire audit, you may be here for 2 weeks with 4 guys. And when I say 4 guys, that's 12 on, 12 off, 12 on, 12 off. So you're here with 2 people from 12 to 12 and then 2 people from 12 to 12. So you're doing 24 hours a day for 2 weeks to audit just the wires in this room. And it all boils down to you taking your information and putting it on paper to tell the next set of people what to look at. Now when we audit the wires, we want to know what wires in the wall, we want to know what wires in the ceiling, we want to know what the wall plates are, the termination points, the junction points, the punch blocks. Listen to your voice of reason on this. If it's not supposed to be there, it's not supposed to be there. If it's supposed to be there, it's supposed to be there. Boil it down to its essentials, trace the wires out, trace out the power, the alarms, trace everything out. When you're doing your conductor auditing, it's done on paper. You can get all kinds of software, and the software will lead you astray. Put it on paper. It boils down to standardized maps, standardized color codes, standardized cable lengths. You want to know how long the wire is, how is it patched. Now, we're not talking about making measurements at this point. This is just auditing what's there, not actually shooting it with any test equipment. You want to know the signal pathway pair combinations. Is it TSB 568A, 568B? Is it USOC? What wiring standard are you using on that particular plate? Or is it something nobody has ever heard of? It's this wire's here and this wire's over here, and then apparently somebody was on LSD when they hooked the wiring up, which happens more often than not. Or Rohm does it this way, Mitel does it this way, IBM doesn't like it, so they do it their way, AT&T does it their way. That's pre-TSB 568 coming in. Once TSB 568A and B came in, everybody just sort of started getting on the same sheet of music. Before that time, it was not uncommon to have AT&T have one wiring scheme, ModTap have a different wiring scheme, and Siemens having a different wiring scheme. So you had all these different wiring schemes, and all the different PBX systems use all these different wiring schemes. And then if you threw a token ring onto the network, you had this, and then somebody over here had the TTY. So it was a rat's nest. We do have industry standard pinouts, fortunately. 10, 15 years ago, we did not have those industry standards, and it was a nightmare. Color codes nowadays are fairly standardized. They were not so 20 years ago. We need, and it's absolutely critical, that we have as scientifically pure measurement as possible of the conductor lengths. We need to know within a fraction of an inch of accuracy how long that cable is. It is exactly 158 feet, .1 at a barometric pressure of, with a humidity of, with a temperature of. Because the temperature, humidity, and barometric pressure affect the velocity of propagation of the cable, and it's the velocity of propagation of the cable used to determine the length. So the three things that affect VOP, you have to document when you're taking your initial measurements. Once we do that, the first step after we've done the auditing, we can do what's called a nonlinear junction and conductor combination, where we blow a signal up the wire on each combination of wires and see if we get a nonlinear response, which tells us something is on that wire other than copper. So if we have a semiconductor or a diode or a transistor or a bug hanging off the wire, and we blow 900 kilohertz into the wire, and we get a reflection back, there's something going on that we need to go check on. That's usually the first step after we do our audit. Now, when we audit the transmission paths, we have to map out where every cable, every conductor, every wire, and this may be a new word for some of you, fortuitous pathway. Ground is a fortuitous pathway. The metallic ductwork that comes into an area, that's our fortuitous pathway. It is a way that the signal can leak out of an area outside. So we may have the blue-white wire provides one side of the circuit, the ground lead for the power line provides the other side of the circuit, or the alarm system provides the other side of the circuit. So don't think that just telephone lines are wiretapped. You can take a microphone, put it in an ultrasonic glass break detector, use the unused pair or the power pair, transmit the audio back over the alarm system and pick it up at the alarm box and never touch the phone system. So you have to audit every conductor, not just every phone wire, not just every data wire, but every single wire. If it's made out of copper or steel or aluminum and it will conduct electricity, if you can touch one end of it with a stun gun and shock yourself by touching the other end, it's a fortuitous pathway. And it's just something I have a real problem drilling into people is they'll go out and they'll install, millions and millions of dollars installing these classified networks and, hook it up to CiproNet and, they got secret information flowing across it, but they don't filter the power lines. The power lines is a fortuitous pathway. Just because they check the phone lines in the local area network doesn't mean they check the power lines. And again, the location mapping has to have an accuracy to within a fraction of an inch. It's not something where you say, well, it's sort of up here. No, it's exactly right here. It runs directly above this. It's exactly 8 inches up and 3 inches to the side. And you have to know where every wire in the room is. Now, when you audit the switching system, this is the PBX system, you want to know what and let's get into a couple of definitions. There's what's called the generic, which is how the phone comes from the phone company. Avaya defaults a certain way. Mitel defaults a certain way. Northern Telecom defaults a certain way. So there's a default condition that comes from the factory. It may or may not be secure in the default mode. The translation is the mojo you throw on it once you get it. That is the program that's actually running in the computer that runs the PBX system, which may deviate from what the phone company provided you with. So if you get like a G400, it comes configured a certain way, but that isn't necessarily what you have on your hand. So we have the generic and we have the translation. The translation is the program that the application, the generic is the operating system, if you will. Now, we need to find out what is different. The way that we do that is we take the generic, we take the translation, and we say this is the default from the factory, this is how we configured it when we installed it, what is it now? Has it changed since we installed it? If it has, what exactly has changed? We want to know, is it safe? This is something that you want to perform in a corporate environment bi-weekly or monthly on every phone connection in the company. You go into the operating system of the phone system, the operating, the admin port of the phone system, you download your setup, you analyze it. Believe it or not, the easiest way to analyze it is to import it into Excel and then compare last month's to this month and flag what's different. Always reduce it to hard copy. Never base it on, well, I did it last week and I'm not going to print it out for this week. I'm just going to go off that's the path to destruction. Once you have it, reduce it to hard copy and not necessarily have somebody witness it, but have it filed somewhere so that you can go get it from a secure environment, open the 3-ring binder up, and go, okay, here it is for this week. Here it is for the week before that. Here it is the week from before that. Because if you have some monkey business happen, some hacker gets loose in your phone system, some script kiddie gets loose in it, some phreaker gets loose in it, it may go on for months before you catch it. If you're auditing these things bi-weekly or monthly, the problem's not going to go on for very much longer until for you to catch it. Usually the modifications to the switching systems are done through the maintenance port, which is one of my real points of contention, because people don't disconnect these ports. They connect them at the dial-up modem, full backdoor access into the whole PBX system. You can piggyback this extension onto this line. You can manipulate, you can download voicemail. You can just raise holy hell with the diagnostics ports. And the easiest way to get around that is to buy an egg timer. Put a switch on the egg timer, you crank that egg timer for 60 minutes, it connects the diagnostics port, you call AT&T, you say, okay, go ahead, dial into my modem, and then after 60 minutes, that clock runs out and it removes the power from the dial-in modem. Cost you $3. Your phone system isn't secure, it's more secure. Now, when you're auditing the instruments, this is where we start getting into the bug sweep side of things. You're looking for tampering with the instrument. You're looking for uncontrolled accessories. You're looking for handset cables that shouldn't be there. You can get on eBay, and for $9, $10, you can buy a handset cable that you can plug into your phone system that's a transmitter. The cable itself that goes from the handset to the phone has a transmitter built into it. And most people aren't going to pick up on that. So if you have a non-standard accessory, you have a risk on your hands. In the case of the cable that goes from the phone to the wall, the same thing. You need to make sure that everybody has the same cords, everybody has the same handset cords, everybody has the same swivel adapters, that you don't have any Bluetooth headsets. I don't care how busy the secretary is, it needs to be a hardwired connection, not wireless connection. Power supplies are a real problem, especially in secure environments. Somebody can go into a classified area, take out a STI power supply, put a bug in it, go back in the classified area, plug it in, it's transmitting room audio all the time, or it's transmitting when the Chinese government gives it the command to download the information from the power supply, and it's not going to show up during the scans. It's absolutely critical that you always get your power supplies, your handsets, all of your phone accessories from a trusted source, and that they're screened before they're introduced. And in cases like power supplies, cords, cables, those are as important to check as your demarcation blocks and your terminals. If you're not checking your power supplies, like on a STU3 or a STI or a secure fax machine, if you're not checking those external power supplies, you're just playing games. Bugs have been found not in STU3s, but in STU3 power supplies. For those of you who work in government circles, you know what a STU3 is. It's a phone you use to talk about classified matters. The President of the United States has one on his desk. You know, one of those kinds of phones. Now, one of the issues with power supplies and phone systems, you may have what we call a low bandwidth device where you're transmitting room audio, but not at 3 kilohertz of bandwidth. You can take the room audio, record the conversation, slow down the bandwidth, and bleed it out over a secure connection. So if you have bandpass filters that cut off for power lines, they'll roll off at 300 hertz. So it will not let any room audio pass above 300 hertz, or 400 hertz if you're in the military, or 500 hertz if you're in the military. So what a spy will do is he'll have a bug that stores the audio and then transmits it at a very low bit rate to get it through the filters. And you find that with a spectrum analyzer and by doing long-term monitoring. That has been found in classified facilities, where somebody has installed a device specifically to subvert the filters in the SCIF. This is something to be concerned with. One of my favorite are proximities to RF emitters. FBI agent over here has a Nextel. He's very proud of his Nextel. He picks it up, he takes it into the SCIF with him, where he picks up the STU-3 and makes a call and has a classified discussion. He has just disclosed classified information because that Nextel phone, when it hits that STU-3, it's actually carrying classified information and classifying keying information outside of that room. If you have something that is protected or classified, or you want to keep private, you keep anything that emits an RF signal at least 3 meters away from it. It doesn't matter if it's a Bluetooth headset, a Nextel phone, a GSM phone, a CDMA phone. It doesn't matter what kind or what frequency. What it matters is what's called close field. We don't want to be within 3 meters of a thing that is classified or sensitive. So if you're sitting at home working on your computer, a spy may not be able to download the video off your LCD screen, but as soon as you fire up your BlackBerry, boom, now he has something to piggyback the signal on. When you're auditing the instruments, we're doing a basic electronic analysis, we're doing an actual audit, a visual inspection, an intense physical inspection where we're looking at every component on a circuit board on a single telephone. One telephone line goes to the PBX. 750 plus separate measurements that have to be documented. Not 1 or 2 measurements, not a black box with a red you're dead and green you're good. 750 plus measurements, bare bones. For one telephone, I can generate 200 pages of report. For one telephone. Common penetration hacks and attacks. Common manipulations we see them on the Avias, the Nortels. There's the raw hacking of the switch. It usually targets the PBX. There's also what we call a blip box, where instead of manipulating the PBX, you go to the IDF, which is the wiring closet. You plug on to where there's a digital set, and you transmit the command code as if you were the PBX to open the microphone up on the executive's desk phone. So you're not transmitting it from the PBX, you're transmitting it from the wiring closet. It's referred to as a blip box. There's appropriate countermeasures for all of these. With VoIP, it's extremely high risk. They rarely use a mechanical hook switch, and I'll get into mechanical hook switches in a minute. Most do not have mechanical hook switches, which means they're running live audio all the time over the connection, which is a real problem if you're sitting in your living room with a phone hooked up, plugged into a cable modem, and everybody in your neighborhood can listen in to what you're talking about in the room, and you're not even on the phone. The firmware can be remotely modified on most VoIP systems, most commonly the Cisco. A number of people know about the Cisco hacks, where you can actually get into the firmware on a Cisco VoIP phone and just raise holy hell with it. VoIP phones are extremely insecure. They're getting better, and over the next few years they'll become more secure, but right now they're not very secure, and it's the network connection that provides the choke point or the fatal funnel. There's multiple packages available that will allow somebody to monitor VoIP and reconstruct the audio. For example, Can-Enable, Wireshark, there's many others. There's new software coming out every month, downloaded free of charge on the internet, and it's pretty much plug-and-play functionality. You don't need to know anything about VoIP. You just need to go, hi, I'm a script kiddie, click, 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 click. That's all it requires. It's not anything special. Reasonable VoIP audit efforts. Inventory all of your VoIP network connections. Only plug a VoIP phone into a true switch, not a hub, a true switch that maintains traffic statistics on a port-by-port basis. So we know that this port is dedicated to executive so-and-so. Executive so-and-so is on vacation this week, hence that port should have little or no traffic on it. If we have a tremendous amount of traffic, when we know that phone's not being used, we might be passing room audio all the time. You do the same thing on the network. You plug into the network using an inline analyzer at 3 o'clock in the morning when no one's in the building. If you've got backbone traffic on your VoIP network, you may have a problem. You should not be using VoIP phones that transmit room audio all the time, and they should be transmitting just enough data to maintain the connection or to recognize the connection, but no more. You shouldn't be transmitting room audio like some hotel phones do. They transmit room audio from the phone to the PBX system, so the PBX system will tell the proprietors of the hotel if somebody's in a room or not. So they listen into room audio, and if they hear room audio, they knew the room's occupied, but they didn't pay. And that's how a lot of hotels, not to name any names, but that's how a lot of hotels determine if somebody's occupying a room. It's based on sound that they pick up over the PBX system because all the phones in the hotel are open mic'd. And now a lot of them are turning to VoIP phones, and they're doing the same thing with the VoIP phones. To detect and defeat VoIP attacks, look for unregistered IP addresses on your VoIP network. If you have a VoIP network and you've got 8 people plugged in, why do you have 10 IP addresses? Look for a non-VoIP asset on your VoIP network. Do not plug a laptop into a VoIP network. Here's your VoIP network, your VoIP hub, your VoIP backbone. You don't share any connections with data connections. At one point, everything's going to come together. But the general closets throughout the company, here's the switch for the VoIP, here's the switch for the data. The two are never mixed. When you do that, you're causing a lot of nightmares for yourself. Make sure it's a hub, not a switch, and check the machines used on the backbone. My personal preference is I'll use a bridge where I have 2 cards in a machine. I'll plug it into the backbone and do a man-in-the-middle type of monitoring, and I'll monitor everything that's going across the backbone in, everything that's going out, and we'll put it there during the weekend when we know there's no traffic. Then we go around to all of the rooms and we put audio transmitters in all the rooms, like a radio or a CD player, and we're looking to see if we're getting any kind of traffic at all on the backbone, on the VoIP side, from any of the rooms anywhere in the building. It's amazing what you'll find. Suspect data traffic on an unused VoIP phone line. So if there's not supposed to be somebody plugged in to your VoIP network and you're getting data traffic on a wire that nobody's supposed to be on, you need to be concerned that somebody's compromising the integrity of your VoIP isolation. To secure it, you also utilize smart switches, and I can't drive this home enough. Make sure it has statistics. You're going to pay more for your hub, but it's going to end up costing you a lot less. Keep your VoIP terminals on a dedicated network, dedicated gateways. Keep them off the main network. Do not integrate it into the main data network for the company, and lock down the instrument firmware. The best way to lock it down is to remove the jumpers from inside the phone. Flash the phone, get it loaded up, remove the jumper so that the only way you can reflash the phone is open the phone up and take the jumper back out or put the jumper back in. Once the phone software is loaded, you don't want people changing it. Now, when you need to have this stuff done, please use the professionals. There are some things you can do on your own with a flashlight, with a voltmeter, with ladders, but when it gets really down to keeping secrets, you want people to come in with laboratory-grade test equipment. There is no such thing as a fast bug sweep. It's long, tedious hours. It's hot, sweaty, nasty work. You're up in ceilings. You're crawling down, crawling around on the floor. You're pulling up wires. It takes hundreds of test forms for a typical sweep. It can take hours per phone. A full exam for one phone can take 8 to 12 hours for one telephone. That's one telephone line, one port on the switch, and the wiring in between, and that assumes it's not a huge corporate environment. You can do a cursory inspection, that will take approximately 4 hours per telephone. But when you're talking about telephones, they're one of the most dangerous things that you have in a company or in a home, and they can be exploited in ways you'll never know. And you may never know that they've been exploited until something very embarrassing comes out a couple years later. TSCM is the inspection by a technician or an engineer of a physical place or item. It involves somebody who's highly technically trained. A vast amount of equipment is required. We're not talking about hundreds of pounds. We're talking about tonnage of equipment. When you go out to do a project, you're actually bringing an entire electronics laboratory out to the client site, not a couple of suitcases. You could actually have several tons of equipment. If you're flying out, it may only be 500 or 600 pounds. If you're driving out, it may be 8,000 to 10,000 pounds of equipment. There's specialized protocols. They're actually fairly standardized, and it's a scientific procedure, scientific protocols. It's no black magic. It's all engineering. In the United States, there is over $6 million worth of illicit surveillance devices sold to the public each day. You go to New York City, Washington, D.C., Los Angeles, you're going to find 100 stores that will sell you that bug for $10,000. That bug costs $3 to make. You will, if you're so inclined, you will make more money selling that bug than you will selling an equal weight of cocaine. It's far more profitable, like with Pelicano. He was taking allegedly taking $500,000 retainers from people to install 1 or 2 bugs. That's a lot of money. If you divide it out by the street value of cocaine versus, you know, and look what happened to the governor of New York. A couple of fairly inexpensive wiretaps destroyed an entire government official and his administration and everything with just a few pennies worth of electronics. What's that?
His actions might have had something to do with that also.
What's that?
His actions might have had something to do with that.
Probably not. No, he's a honest fellow. He would never do anything he shouldn't. God-fearing, wife-loving. From what I hear, sheep as well. To recap, we want to map out all the wires that are present. We want to rip out all of the unused wires. We want to pull back 30 feet. We want to not just cut off, but we want to cut off and then pull back so that it can't be drawn back into our area and reconnected at some future point. You want to certify and seal all the wires that are going to be used in a controlled environment. And I don't just mean a classified environment here. I mean, if this is a corporate boardroom and you want to keep your corporate secrets secret and you don't want people playing games with their stock prices, you better make sure that this room is secure. Because somebody's going to install a bug in here just so they can get a slight advantage in the stock market, and all they need is a little bit of information to make millions and millions of dollars very quickly in the stock market. So we're not talking about, this is a listening facility for, some classified intelligence agency. We're talking boardroom stuff. We're talking an architect's office. We're talking a professional photographer. Professional photographers are absolutely nuts about the electronic security of their shooting, because they're shooting a year before the fashion hits the street. If Ralph Lauren or Victoria's Secrets is having a photo shoot done, they're going to have a bug sweep done of the studio before the photo shoot's done, because they don't want any of the information that is shot for the catalog that comes out next year to be leaked to their competitor. So they're absolutely, and some people, they don't realize how valuable the secrets are. We're not talking defense secrets here. We're talking about the color of underwear. Woo, yeah, woo. And you should always have TSCM services performed on wires before you have live usage. Ideally, you want somebody to come in and do TSCM services before an area is wired, then while the area is wired, and then once it's all wired and before anybody moves in, you want somebody to come back and recheck it, and then you want to come back and have it periodically checked. And how often you have it checked is a judgment call on behalf of management. You really don't want your sweep company telling you how often. I'd like to come back in every 2 weeks and do it, but it wouldn't be prudent and it would be ripping my client off to do that. Some clients once a year, some clients once every indictment. You know, client gets indicted and, you know, they want us to come in and do a bug sweep, and we go, why? Well, we can't tell you why. Well, let's see, legitimate, publicly traded company, defense contractor, okay. Yeah, no problem, we'll come in, and while we're there, they go, oh, our executives just got indicted this morning. Oh, crap. We've already gone over this. You want to look for traffic patterns. You want to log your packet headers, daily or weekly auditing of your VoIP networks. You want to know the inside of all of your phone instruments. If you're in systems admin, if you're a security person inside a company, you work for a defense contractor, you've got to know what the inside of your phones look like. Don't be afraid to get a screwdriver out and start breaking stuff. It's okay. It's cheap to replace it. If you don't know what the insides of the phone systems look like now, you're not going to know if they've been modified in the future. And the inspections of the insides of the phones is something that every sysadmin should be capable of doing. So if you're a security person working at a company, a network administrator, phone administrator, security person, you better be able to take the phones apart and put them back together. And if you can't, learn how to do it, and do it so you can very quickly, if your boss calls you up and say he thinks his phone is bugged, you need to be able to open his phone up real quick and go, no, everything's fine with the phone. Here, let me check the PBX translation or the PBX configuration. No, everything's fine there. Go to the phone room. Oh, crap, there's a tape recorder hanging off his line. You don't need specialized TSEM gear to do this. You need a flashlight and a ladder and a couple of screwdrivers. Learn about hook switches. We're going to cover that momentarily. Know what your wiring blocks are supposed to look like. You don't necessarily have to audit them, but you need to know where they are, what they look like, and what shouldn't be there. If you go into your phone room or your wiring closet and you look on the floor and there's wrappers from cassette tapes laying on the floor, you might have a problem. I've had that happen where I'm walking around doing my tour, haven't brought any equipment in the building, I'm just walking around with the executive and he's showing me where everything is, and here's the phone closet, and I'm going, shit. And I point on the floor and there's cassette tape wrappers, and the spy was nice enough to actually have left a receipt from Radio Shack with his name on it. So it was like, oh, okay, so then we go to accounting and they pull the guy's American Express card and it matches with the receipt from Radio Shack. So then they go to corporate security and corporate security goes, okay. And they go collect the guy, they bring him in, sit him down, and he confesses his sins, and they go, you know, they get a cardboard box and he does the walk of shame with no, you know. If you can get it, try to get video coverage of the outside and inside of your IDFs and MDFs. These are your electrical closets in your phone rooms. It's prudent to put a camera in your phone rooms way up in the corner so you can see what is being done to your wiring blocks. This is always fun when like Avaya or AT&T comes out to work on your phone system and they claim they didn't unplug something and cripple your entire phone system, and you go, but we have video of your guy doing it. It also helps you repair the damage that the phone guy did. As far as the demarcation points, you want to map out all your copper appearance points. You want to map out where the cable bends, where it's bound up. So for example, if a cable goes this way and then it makes a 90-degree turn, you want a written note of where it is, what it does, where it bends. You want to make sure that your bends aren't too tight because they'll throw errors on your time domain reflectometry because you're binding the capacitance up. So you want to make sure you have nice even bends on everything. And if you're installing your cables according to a BICSI standard, it's going to be all nice and neat, and it's just going to be a beautiful thing. You want to make sure that you check your above ground and your below ground sites. So don't just think phone wires, telephone poles. Also think telephone wires 3 feet below ground. When you do your pole walks, we talked about this a few minutes ago, you want to map out all the phone poles back to the central office and then forward. So you go from your location back to the central office, and then you come back from your location back to the very end of the cable. And if you have a 30,000 foot cable and you're 15,000 feet down line from that, you're going to have to check another 15,000 feet going the other direction, because the road isn't just from here to there, it's from here to there and then back this way as well. And this could be involved, you may be involved in walking 2, 3, 4, 5, 10 miles of poles. And you may have to break your pole walk over 3 or 4 days. Now we get into the good stuff. This is our basic telephone instruments. Anybody in here can get these and learn to operate them very quickly. On the far side, we have old school. We call that a Brown meter. They're still in production. In many cases, this is the only instrument the phone company brings out with them to work on your phone lines. And that's it. That device will find some wiretaps, but it's basically, it's a red you're dead, good, green you're good type of a thing. Next to it, we have an old school IBM 70s vintage analog meter. The nice meters, old school. This is new. This is the Fluke 289. This just came out within the last couple of weeks, last couple of months. It's an outstanding device for looking for mischief on your phone lines. Highly recommend them. 450, 550, no more than 600 bucks. You can do some miraculous things with this, and you don't have to be a TSCM guy. You just get a banjo, hook your test leads up, and I'll show you how to make some real quick measurements that will show you some neat stuff quickly. You also want an oscilloscope. If you have wires, you need an oscilloscope. My preference is the Fluke 199C because it has very high bandwidth, which means it's great for time domain reflectometry. You don't need an extra box to shoot your lines. In fact, this is higher resolution than most time domain reflectometers. And this has a spectrum analyzer built into it, which is cool because that's one less piece of equipment I have to hump from the truck into the client's office. So for quick checks, a digital voltmeter and an oscilloscope will get you further than anything else. It's like, if you're into emergency medicine, you've got your stethoscope and your blood pressure cuff. Those two things will tell you more than anything else you ever want to know. The basic instruments. Now, they're not high-end, super sophisticated phone analyzers that cost $50,000. We use those too, but this is where you start, and this is within the scope of anybody in this room. Now, this is time domain reflectometry of an 1,800-foot DSL drop. What we have is we induce a pulse here, ping, and we watch it bounce off of the turns and the kinks in the cable, and then we see a return pulse here, just like sonar on a submarine. And it's ping, wait for the echo, ping, wait for the echo. And every little fish in between the submarine and the boat, we can actually see on here once you learn how to interpret it. And it's some very simple math on how to do this. If anybody wants, after we're finished here in about 5 minutes, I'll explain how to do this real quick. We can also hone in on specific return responses and determine exactly how far it is within a fraction of an inch. Now mind you, we're talking 1,800 feet here. I can go, well, there's a wire that's 6 feet long, 1,000 feet from here. This is a commercial time domain reflectometer. It's easy to use, but they're notoriously inaccurate. They are designed for people who are not the most technically sophisticated people. They tend to be, you turn it on, you press one button, and it does everything for you. It doesn't give you precise measurements. They usually are not calibrated to a standard. Oscilloscopes will be calibrated to a standard. And it lacks detail. There's a lot of, I'm going to throw a slide up here in just a minute of a TDR and a scope looking at the exact same thing, and you're going to see a significant difference between the two. This is a commercial time domain reflectometer. This is an oscilloscope. The waveforms are a lot crisper. There's a lot more detail that we can see down here that is completely invisible on even the most expensive TDR made in the United States. This is I believe a $6,000 or $4,000 TDR. This is a $2,000 oscilloscope. So, this is a very basic measurement. This is what we call a Princess telephone. So actually an old AT&T phone. To make a measurement, you need 2 things. You need a meter and a banjo. This is a mod app made by Siemens. They go like 10 bucks, 15 bucks. You have to have something to give you access to the copper of the connection. So we have copper connections here, here, here. In this particular case, we have the phone is only using 2 wires, but we're actually we have accessibility to all 8 wires on this. In this particular case, the phone is hung up. We have minus 49 volts, 49.32 volts. Actual voltage measurement doesn't tell us anything. But if we go into an office and we check everybody's phone, and this guy's 49, 49, 49, 63, we might have a problem there. So what is different? So from a layman's perspective, and by layman I mean the people who are involved in technical security for a company, you don't have to go out and buy $300,000 worth of equipment. You need to go out and buy a $500 voltmeter that any student here at MIT is going to have anyways. Basic equipment, basic examinations, nothing really special. When we take the phone off the hook, we drop down to our biasing voltage. We actually have 2 voltages here. We have our DC biasing voltage, which is what gives us talk voltage. And then if you look below it, I have another screen I'll blow up in a minute. You can actually see that we have 0.181 volts of AC, which means we have an indication that we have audio on the phone line. Now, if this phone was hung up and we had a similar signal, that may be passing room audio through the line. So if we have more than 500 milliamps or 500 millivolts of audio or of AC, we may have audio flowing down the line. So in this case, we have dial tone. If we hung the line up and we still had AC volts, we may have audio bleeding through the phone line, either through hook switch bypass or some other mischief. This is just an enlargement of the previous where I brought it back up. This is what room audio looks like on a voltmeter. You're not spending $4,000 on an audio amplifier. You can see it clearly and measure it clearly with just a cheap, relatively cheap digital voltmeter. This particular voltmeter also gives us the ability to do diode breakdown tests where it will actually sweep voltages over the lines that we're examining and will tell us if we have a diode out there. Most bugging devices have diodes and semiconductors. So again, with a Swiss Army knife of voltmeters, you can modern Swiss Army knife of voltmeters, you can actually see if you have diodes hanging out there. So if you have a bug hanging out on a phone line somewhere, this will say, hey, you know, I've just disconnected all the phone and the PBX, and it says I still have diodes out there. My God, somebody must have put a transmitter in somewhere, or a hook switch, or a bypass, or a slave device, or some kind of mischief. The new, and I'm not just picking on Fluke. I like Fluke. It's a nice product. But any of your modern digital voltmeters will let you do this. This is a high mega ohm insulation breakdown test. It used to be we would throw 600 volts on the telephone line and listen for the crackling as it jumped across the insulation. Nowadays they don't do that. It's all computerized and you're generating a couple of volts and no more, so you're not going to blow your phone system up like we used to do in my government days. This is we've disconnected the phone, we've disconnected the PBX, there's nothing on the wire. This is what it should look like. This is essentially infinity impedance, 256 mega ohms of impedance. Maybe somebody stepped on the cable and it interrupted the insulation a little bit. Now, if somebody throws like a law enforcement slave onto this line, it's going to make a significant difference in this measurement, and this is an FBI slave device on a bugged phone. The FBI, I'm sure, would be very upset if somebody hooked the same wire up, the same situation, same measurements up, and they go, oh, I have 40 mega ohms of impedance on my line, something's not right. And they go out and they go, oh, somebody's put a slave device on my phone. This will actually detect most law enforcement bugging devices. Use it with great care. Now, we're going to talk about hook switches for just a couple minutes, and then I'll be out of your hair. This is the inside of a 1958 telephone. From the 50s until the early 80s, almost all of your phones were the exact same design, same schematic, same diagrams. You had the dial up here and the switch here, and they made a billion of these springs and a billion of this and a billion of the ringer. The phone, essentially, if you took a 1979 phone and a 1956 phone and you put them next to each other, you'd go, my God, they're brothers and sisters. Okay. Within the phone, we have the ringer or the clapper. We have the actual receiver here, and we have, this is mechanically connected into this area, and I'll open this up in a minute. This is the hook switch. This is the most dangerous part of the entire telephone. This is the dial, where, for those of you who are too young to remember it, you put your finger in it, and you draw it around this way, you release it, and it ka-chunk, 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 and then you do it again to get the next number. This is before the days of touch tone. Now, in the days of touch tone, all of this remained the same, and all they did is they came out and they replaced your front panel. That's really all they did. Now, this is with the cap off of the hook switch, and what I've done is I put a piece of graph paper behind it so you can see these connections inside. Now, each of these connect to a different part of the inside of the phone. So one is for the speaker, one is for the handset, one is for the line, and so on. Now, the way that this works is when the receiver is off the hook, it draws this bar backwards, closing this connection and this connection, but opening this connection and opening this connection. Audio will now flow through the phone. A clever spy can make the phone pass audio on hook or off hook. It's called a hook switch bypass. Takes a couple hours to teach somebody how to do it. I'm not going to teach it here. Somebody will get into mischief and I'll be testifying in court. We're doing a project for a client, pop the box open legally, and everything in there is labeled. All the T1 lines perfectly labeled. This particular box, there was also a box in here that said Federal Bureau of Investigation and gave the address to their safe house where they had their listening post set up. Not exactly very smart move on the part of the phone company. Yes?
Sometimes those heads are vigorously defended by hornet nests.
Yes, they are. And hornet spray is carried on all the trucks, as are EpiPens. Fiber. Contrary to popular belief, fiber is easy to tap. Anybody who tells you otherwise know not of what they speak. Fiber is higher bandwidth than copper, which makes it very attractive to a spy because there's more intelligence on it. It's harder to detect because you don't have the major dropouts, and with a fusion splice onto fiber, which is the preferred way to splice into fiber, where you actually melt glass to glass, it's going to be very difficult to detect, and unfortunately, there's a huge illusion of security about fiber. You can have fiber that's just been pawned all over the place, and you're not going to detect it very easily. Do not ever think that a fiber optic network can't be wiretapped. It can be easily wiretapped, and you don't have to use anything more than a small handheld fusion system. And you can actually have 8 cables running in here. You're using 6 to set your rings up. You've got 6 fibers you're not using. You can actually bridge all of those fibers back to an off-site location. Did I see a hand? Oh. This is our typical fiber optic multiplexer outside. There are versions of this that are inside a lot of office buildings, even small suburban office buildings. Your local Walmart typically will have these. In the wild, you're typically going to see behind it is a copper back here. This is the copper sack. This is fiber optic. The code up here tells us what it is. Also the power. You don't need power for a copper system. You do need power and lots of it for a fiber system. If we go around back, we'll actually see a plug where we can plug in a generator in case we have an extended power outage. This is like a holy grail for an eavesdropper. 3,500 services in here, T1s, T3s, ISDN lines, DSL lines galore, 3,500 voice lines. When it leaves here, it leaves on this particular system, it leaves with this one had 2 fiber rings in it. There were 4 active single mode fibers, 2 inactive backup fibers, and there were 6 dark fibers. It was 3,500 active phone lines, a variety of DSL lines, T1s and T3s. If this was near a defense contractor and somebody hit this box, they would own that defense contractor. This is a terminal. This is not a network interface device. There are 2 terminologies that we have to be careful of. A NID, or demarcation point, is a physical location on a premises where you stop owning the wire and the phone company starts owning the wire. It is mandated by federal law. This is not a NID. This is a terminal. So we've gone from the client's home to the NID on the side of the client's house. We've gone underground out to the telephone pole. That cable between the house and the telephone pole, the phone company owns. This box the phone company owns. This telephone pole the company owns. On the left, my name is Jim Atkinson. I'm the president of the Granite Island Group. Thanks for having me come and speak today. We're going to be talking about telephonic defenses against the dark arts. This is primarily going to be talking about phones, how phones are bugged, where phones are bugged, how to stop phones from being bugged, how to audit voice over IP systems, historical, what some of the penetration points are, how to protect those penetration points, and all kinds of good stuff along those same lines.
Is there a way to go back into monitors and change the refresh rate? It's the videos going like this. Does anyone know how to do that?
Yeah, he just did it.
It's up at 75 hertz.
Change the shutter speed on the camera to compensate. What happened is you turn the overhead lights off, which, if you turn the overhead lights back on, it should clear up your flicker problem.
Yeah, well, actually, I closed the door over there. I closed the blind, but that's okay. I'll try to adjust it from here and see. But yeah, okay. Just keep
Okay. You have 6 primary weak points in the telephone communication systems that you need to be concerned with. We have the instrument itself, which is the proper name for the device you put your ear and your mouth to and that you speak into. Technically it's not a phone, it's an instrument. Then we have the local distribution, or the in-house wiring. That's the wire that includes the jack, the wire that goes between the jack and the instrument, the wire that goes from the jack up into the walls and the ceilings, and down to cross-connect locations. We have the local switch, or PBX system, which most of your corporate entities and government entities will have. This can be as small as a bread box. It can be as large as a semi-truck. The local switch is something on your premises, not the phone company's premises. And at each of these, there's a different penetration point that somebody can hit. Then we have the demarcation, or the network interface. That's where we go from your property to the phone company's property. We have the transmission system, which is almost exclusively owned by one of the phone companies. This includes your telephone poles, the fiber on the line, the copper on the line. This is stuff the phone company installed for their own use, not yours. And then we have the switching systems, also referred to as a central office. Now, from switching systems to switching systems, we have transmission systems between those. We can actually penetrate any of these 6. We can penetrate the 7th, which was the trunks between switching systems or central offices, fiber optic communications, and the list can actually go down another 10 things, but these are our basic 6 items. Everybody has one of these or a variation of these. These are 2 of the most exploitable phones made on Earth. This is an Avaya system. Anybody in the U.S. government probably has one of those. This is one of the old Merlin systems. These were great. They gave you 4 pair of wires. You only used 3, had high current, all kinds of mischief afoot with this. The Avaya system, well, let's just say the Avaya systems are notoriously insecure. And you can just have some horrific pawnage of an Avaya phone system. These are our wall jacks. Years ago, we only had to worry about 4 wires, 2 pair. This is the old prong jacks. Nowadays, we're looking at 3, 4, 5, and 6 connectors. Each of these connectors have 8 wires plus ground. So you can easily have 40, 50 wires in a single jack now, plus ground. And you only need 1 wire to make an incoming connection and 1 wire going out to make an outgoing connection, which is why we have to consider ground, because you may be doing a project and you're not getting audio on any cable pairs, but you are getting audio on the brown-white pair to building ground. We go into the phone area, start looking at things, and we're going, wait a minute here, some amateur twisted these together. This is very amateur. Everything that he used he bought from Radio Shack. It went to a tape recorder. The law enforcement authorities were highly amused when they came out and saw the hatchet job he had done. Basically all he did is he added a patch cable and did what we call a second pair exploit or a spare pair exploit. This is another typical defense contractor's facility. This one is bugged. Big questions: do we have extra wires? Do we have transmitters? Do we have recorders, bridges, taps, slaves? The slave is a type of eavesdropping device. In this particular case, we have the sack that comes up from the cable company over here. We have you'll tell the yellow are your digital lines coming in. This is the breakout panel for the central office. And within this board, we actually have a wiretap and a slave. On the next slide, you can see it better. I'll give you a little hint as to where it's at. It's a left. This is the 110 block. If you look on the left side and you count 9 rows down from the top, you see a little silver reflection. The spy, when he installed this particular slave, did not opt for a low visibility one. It was a nice stainless steel, kind of difficult not to see if you had a strong light. It's actually behind, you'll notice it right here. And this cable was the actual cable that went back to the listening post. And this was at a defense facility, a defense contractor's facility. The only way you're going to find that, you can get lucky with a flashlight, which more bugs are found with flashlights than any other creature on Earth. Low tech, you get a dental mirror and a flashlight, you can find all kinds of stuff if you have enough time. An extensive physical audit and electrical audit will find this very reliably. The electronic test equipment can see things your eyes can't. So if you just use your naked eyes to try to find something like this, or a dental mirror, or very basic test equipment, you're going to miss this. This particular place had been through a number of sweeps before, not by us, but government sweep teams had come through and they had missed this. They estimate this was in place a year and a half and had been missed on 6 inspections because people just weren't paying attention.
Whose pair did it go to?
What's that?
Whose pair did it go to?
I'm not saying. But it became a federal case very quickly. This is what should be locked. There should be a lock on here. As you can see, there is chafing and abrasion to where a lock used to be. You can also tell by the scuffing and chafing on the paint that this container is gotten into on a very regular basis. Some of you know what this latch is to, some of you don't. That's what it's to. This is your typical cross-connection box. As a rule of thumb, they are not secure. Anybody who has the wherewithal can walk up to it, usually with no tools, just lift that handle up, swing that door open, and welcome to the gates of heaven. If they are latched, it'll be nothing more than a 5/16 or a 3/8 socket. You just put the socket on it, unscrew it, opens right up. If it is locked, usually all the padlocks within a 30-mile radius, it's all the same key. So if somebody has the key, and usually all you really need is a bobby pin to open these. They're nothing special, which is unfortunate from a security perspective. If you have one of these outside your home or your office, you need to go buy your own padlock and slap your own padlock on it and wait to see when that padlock gets cut off, and then play a game with the phone company called they keep cutting my padlock off and I keep putting another padlock on it. As we actually recommend our clients play that game and just buy about 50 padlocks, and once a week security goes over, makes sure that their phone box nearest to their office is padlocked, and it'll drive the phone company nuts. But that's why they have bolt cutters on board all the phone trucks. And if you really want to be cute, eventually they'll put a padlock on it, and nothing will prevent you from putting your own padlock on it after that. There's lots of extra space. The pairs are often labeled. For example, I wouldn't recommend doing this, but God forbid somebody go up to the presidential estate in Kennebunkport, Maine. The president has one of these across the street from his house. It's unlocked. If you open it, his phone line is tagged. The Secret Service's phone line is tagged. When I say, I don't mean bugged, I mean it says Secret Service hotline. So these are usually remote from the target. And what I mean by remote, they're not under the immediate control of the target. So if there's one of these for the hotel, it generally won't be on the hotel property. It'll be down the street somewhat. These are very easy to access, and professional eavesdroppers absolutely love them. There is so much mischief they get into with these boxes. This is what the inside of one looks like for those of you who've never gained access to one legally or otherwise. You typically see these by the side of the road. They're generally not labeled. If they are labeled, there'll be a code, which will be like box 57, which indicates it's the 57th. Or if they're really fancy, if it's a fiber optic unit, they'll actually have the CLLI code, which is the network address code for that particular box. So the phone company can find it real easy. This particular one, for those of interest, this one was legally accessed. So if you look on the far right-hand side, these are codes written inside the door to include the password for the local maintenance system, so you can actually plug in, tie your computer into the local switch, and gain full access, perform all kinds of naughty mischief and so forth like that. Not that anybody in the room would do that. It also contains the 800 numbers to call customer service, the wire room, as well as a note down here as to which pair in the phone closet has the most salacious commentary, and the escort agencies and stuff like that. They're actually noted on so that the phone guys, when they're there working, if they're bored, they can plug in and listen to entertainment. Pair number 557 in this box was in fact tapped. This was what we were called in to find. If you look very carefully, you can see that the craftsmanship on this particular set of wires, the wire is the same because it came off this spool, but the craftsmanship and the installation technique is an amateur. A professional is not going to make this mistake. It's all going to be neat as a pin. That's one of the key things that you look for when you look in these boxes, is to see who's been working in it or on the junction panels or the terminal blocks that's not neat as a pin like it's supposed to be. If it's not neat as a pin, somebody's been fooling around there. It may have just been a drunk phone guy, or it may be an amateur wire guy. It may be a private investigator who does 3 or 4 installations per year. They tend not to be very good. They tend not to be very clean in their installations. This is one of my favorites. You open the phone box up and you're doing a sweep, and lo and behold, we come up with, it's a 56 kilobit line to a German company with the account code on it, the address, everything that a spy needs to exploit. This was not our client, this is somebody else. We used to have 4 conductors, 32 is pretty much standard now. You could have 3, you could have 4. It could be ISDN services that have been retrofitted. The case in the middle is a situation where somebody had 2 voice telephone lines in their office and they changed to VoIP, which we're going to talk about. As you can see, the data network, this is their VoIP telephone. Very bad news. This is what is in the back of most of your phone boxes, or your phone PBX, your phone rooms, your cross-connect panels. A lot of people have never seen what the back end of one of these looked like. This particular one has actually been wiretapped. This was a brand new installation, and before the government agency that was going to be moving in here moved in here, Somebody actually disconnected the wires, put in a wiretap, and they got caught. But this is what a wiretap looks like. As you can see, there's nothing really visible. There's no magic black box hanging off of that. That is a wiretap. This is typically what we find up inside ceilings. This was taken at a defense contractor's facility. If you've been up inside a drop ceiling, these are your ceiling tiles. This is the back wall. This is a 15-foot high gap between here to here. It's a mad jumble. There's typical no documentation. It's rare to have documentation as to what kind of wire we have up in there. This is a very common problem. If you look very carefully, you'll see an audio recorder in there. If you look very carefully, I'll let you look at that for just a moment. This particular problem, it required us on site. This one mast took 4 days of digging through, identifying, auditing, tracing out all of the wires. We found the tape recorder right away. It was actually that very large black box down in the bottom. We found that right away, but then we had to go through and make sure that none of these other wires had anything else on them, because we always have to assume that there's 3 bugs. There's the bug you're designed to find. There's the bug you're going to find if you look really, really hard and spend tremendous amounts of time exhaustively searching. And then there's what we call the spies bug, which is a bug you're never going to find unless you perform every test known on Earth. Yes?
Take off your badge because it's scratching on your leg. Sorry.
I was wondering what was causing the noise. This is a typical hatchet job done by an amateur spy. What was interesting in this case, this wire did not initially exist. What happened in this case is the spy was not very skillful, so he went to Radio Shack, bought wire, literally wired this through conduit to another house, to underground conduit, went in, trenched in the cable, ran this cable from Radio Shack through the conduit. So when we followed this back down with tracing equipment, we traced it right to his house. The blue-white wire is the regular talk. You'll notice here we have orange going to the terminal block, but we also have another orange cable that comes out here. This actually went to a PBX phone. So what he had done is he had given his next-door neighbor a telephone where they had taken the orange pair. He had bought it from a spy shop. He had taken the orange pair and connected it directly to the microphone in the phone. So he had exploited the phone by modifying the inside of the phone so that you always had room audio on this pair, and then this was a regular telephone line.